Hi there folks, today we're looking at graphing hyperbolas, and this is the last of our conic sections. Now this is the one where if we had two cones tip to tip and we sliced down through each of them kind of simultaneously, we get these two parabolic looking curves that face in opposite directions. And so this is kind of what a hyperbola looks like. The thing is in purple is my actual hyperbola. We have a center, we have two vertices, we have two foci or foci, and then we have two asymptotes as well. And so as we look at this thing, a lot of things going on here. You'll notice right away I've got this box in green. That's going to be the key to graphing these things. And almost when you think about these, you're almost going to think of this as kind of a combination of all the conic sections we've done as we graph each piece. They're very similar to parabolas in that they have a vertex and then a focus inside, but then there's another one of those facing the opposite direction. It's kind of very similar to the circle and the ellipse in that it has a center, more so to the ellipse because we have these two axes that open in each direction. Instead of major and minor axes, what we have is our transverse and our conjugate axis. And really, we almost think of this, when you go to graph it, the approach that we take, it's very similar to the way we approach graphing the ellipse, but it's almost like we've taken the ellipse and kind of flipped it inside out. So instead of this thing opening inside of this box, where we've measured these four pieces, it's going to open to the outside, and we're going to use these asymptotes in order to graph this thing. And you'll see what I mean in a moment here. So the transverse axis, this is a segment whose endpoints are the vertices. So when we talk about the transverse axis, it's just the axis that's going across the center and whose endpoints are the vertices. The only reason we don't call this major and minor now, with the ellipse we had major and minor, and the implication was that the major had to be larger. In this case, the transverse does not have to be bigger than the conjugate axis. Alright, so that's the real main difference here. We treat these almost exactly the same as the major and minor, but it doesn't have that stigma on it of the major has to be larger. Here the transverse doesn't have to be larger than conjugate. The conjugate axis is just the other axis then. It's the axis that's perpendicular to the transverse axis, and it has to go through the center. And the whole thing here is that we're going to use that to establish the asymptotes. Really, these two axes are going to give me that green box that you see in the example of a hyperbola up top. The transverse axis lands on my vertices. The conjugate axis just goes in the opposite direction. And what happens is it gives me the establishment of this box, which gives me my asymptotes. And so looking back up here, this is my transverse axis right here, the one that goes across this way, and then the conjugate axis that runs up and down. Alright, so what it's going to do, it's going to establish that green box, which is going to allow me to graph my asymptotes. The formula for this thing, really the exact same thing that we were dealing with when we dealt with the ellipse. The only difference now is I have a minus sign instead of a plus sign inside of there. The a squared and the b squared still represent kind of the same thing, except instead of major and minor, we now have transverse and conjugate. And keep in mind, once again, the transverse axis does not have to be larger. The thing that's going to determine the order is which one of these fractions has the negative sign in front of it. See, when you look at this one, the negative sign is in front of the y, so that one has to go second. Here, the negative sign is in front of the x, that's why that one has to go second. Alright, so we want the minus sign to be in between these. Notice this first fraction is positive, second fraction is negative. First fraction is positive, second fraction is negative. And that's how we establish which order this thing is going to be written in. It's not based on the size of those denominators anymore. Okay? So HK is still the center, A is the radius of the transverse, B is the radius of the conjugate. And then the focal length, we have one more formula here for focal length. Remember, with our parabola, it's 1 over 4a. With our ellipse, it was a squared minus b squared equals c squared. And now with the hyperbola, it's a squared plus b squared equals c squared. It's my actual Pythagorean theorem in order to find this thing. And that focal length is just going to tell me how far to go in order to get to my my foci or my foci here. All right. And the other thing you have to remember is that this is going to follow the transverse axis. Just like finding the focal points in the ellipse, we followed the major axis. Well, here, finding those points, I'm going to follow the transverse axis. Okay? For example, if I look at something like this guy, The center, and just be careful based on where x and where y is. This is going to be negative 4, 3. The a value is a 6. The b value is a 3. And now from here, that's enough information to graph this thing. So I'm going to start at the negative 4, 3. The transverse axis is going to go up and down because it's paired up with the y this time. So I go up 6, and I go down 6. Those are my vertices because the endpoints of the transverse axis are the vertices. So I could write those down while I'm looking at this thing. So that was negative 4, 9, and negative 4, negative 3. The conjugate axis is going to go in the opposite direction, so 1, 2, 3 in each direction. I'm going to mark these with a different color here. And so what happens when you think about that green box that was drawn originally from that first example that I showed you, it's basically just a box. See, like if I was thinking of this almost as an ellipse, if I was drawing an ellipse here, this is where I would draw my ellipse, right? But instead of drawing an ellipse, I want to draw this thing kind of inside out. I want to rip those pieces off, and like this top piece is going to open up instead, and this bottom piece is going to open down instead. And to establish kind of where that should take place, instead of connecting these with an oval or a circular type of pattern, what I'm going to do is I'm going to connect those 4 points with a box. I use a dotted line for this box. And then what happens here, the asymptotes that we were talking about, really if I just connect to the diagonals of this box, if I draw these diagonals, so I connect to the corners of the box, and I go through the center, these are the asymptotes that I've been looking for. And remember, asymptotes kind of determine the end behavior of these things. It's telling us what this function is going to do as it goes to infinity. So basically what happens here is I know that I'm going to start at the vertex and I want to hug this line. And I want to start at the vertex and hug this line. I start at the vertex and hug this line. I start at the vertex and hug this line. And it's a good, so it gives me the appropriate width of this thing and everything. And I just have to start at that vertex. So really my entire graph is based on these a values and these b values. I start at the vertex and then I follow these asymptotes. And then from here to the focal length, I still want to plot my focal points here. So I do a squared plus b squared equals c squared. That's going to be c squared equals 45. And now I'm going to take the square root of each side. And remember, when I take the square root of each side, I'm going to get plus or minus here. And this one, when you plug it into your calculator, gives you about 6.7. So that's telling me to count 6.7 in each direction. I follow the transverse axis. So I go up 6.7. It's going to be right about here. I go down 6.7, which puts me right about here. And now once again I can write down those ordered pairs. I've got negative 4, 9.7. And I've got negative 4, negative 3.7. And that's it. Alright, so I've found all these pieces, and really it's all based on just coming up with the initial graph. So we're going to draw that box using the transverse and the conjugate axis. We draw our asymptotes, and then we start at the vertex and hug the lines, hug those asymptotes. If we look at another one here, this one, the center, looks like 1, negative 2. The a value is 5, the b value is 4. That's the radius of the transverse and the conjugate axis. From here I'm going to graph this thing. So I've got 1, negative 2 is right here. The a value is tied to the x this time. See, x is listed first, so it's listed with my a value. So I'm going to go 5 to the left and the right. That's my vertices. So I can write those ordered pairs down. Looks like negative 4, 2. And let's see, what did I have here? 6. Sorry, negative 2 for that first one. So -4, -2, and 6, -2. And now from here, I'm going to draw the other axis, the conjugate axis, so 1, 2, 3, 4 in each direction. Instead of connecting these and making an ellipse, I'm going to connect these with a box. It's my magic box. This is magically going to give me my asymptotes when it's all said and done. And now I just connect the corners of this thing, and when I connect the corners, it gives me the asymptotes. And the asymptotes, again, give me 90% of this graph because they tell me how wide the thing should be. So after I'm done graphing these, again, essentially what I've done is graphed the transverse and the conjugate axis. The transverse and the conjugate give me that box, which gives me my asymptotes, but the transverse also gives me my starting point here for my vertices. And that's it. So now I have the graph. The only thing left to do is actually find my my focal points here. So I'm going to do a squared plus b squared equals c squared. It's like a 41. And now I take the square root of each side. Don't forget the plus or minus. And the only reason it's coming out plus or minus is because I'm going in each direction. So now I got to plug this into my calculator and get about 6.4. So I just count 6.4 in each direction. 6.4 is right around here. 6.4 is right around here. And then I just have to write down those ordered pairs. So this one was looks like -5.4 comma -2. And this one's 7.4 comma -2. And that's it. Okay. We look at one more here. The center, again this time is -4, 3. Just be aware of where x and where y is. The x is with x and the y is with y. Just like with our ellipse. A looks to be about a 10. B is an 8. And I'm going to rescale this thing this time, so I'm going to go by 2's over here. So -4, 2, 4, 3 right here. That's my center. The A value is tied to Y, so I'm going to go up 5, 2, 4, 5. That's my vertices. And down 5. So those are my vertices. I can write those ordered pairs down. -4, comma 8. -4, comma -2. And now the B value goes left and right. Let's see. Oh, I only counted 5. I don't know what I was thinking there. Clearly it's a 10. Let me try that again. I know how to count. That's how many fingers I have. Oh my. I don't know why I went 5. Awfully strange thing to do there, Mr. Jansen. 2, 4, 6, 8, 10. There we are. There we go. So now I have -4, 13, and -4, comma -7. Now I can go 8 in each direction. And now I can draw my magic box. I can draw my asymptotes. And really this establishes how wide this thing's going to be. I start at my vertex and I hug the asymptote. I start at the vertex and hug the asymptote. I do the same thing down here. Start at the vertex and hug the asymptote. Start at the vertex and hug the asymptote. And that's it. In terms of the graph, now I just need to find my focal points. So I do the a squared plus b squared equals c squared. Once again, I take the square root of each side, and that's going to be a job for my calculator. It's about 12.8. So now I count up 12.8 and down 12.8, 10, 12.8's right around there, 10, 12.8's right around here-ish. And then from there I just need to identify those ordered pairs. We've got the -4, and then 15.8, and then -4. And then that's going to be a -9.8, it looks like. Alrighty. So again, we start with the center. We use the A and the B to come up with those 4 points that give us the box. Then we draw the asymptotes, start at the vertex, hug the line, and then plot your focal points from there. One of the big issues is if this thing is not in the right format already, we're going to have to complete the square twice, and that involves everything that it involved before. The only difference now is I have to deal with a negative sign in here somewhere. The other issue really is I just have to be very careful because of that negative sign in terms of adding the same thing to each side. So very similar to our ellipse, except we have that one extra difficulty of having a negative sign thrown in there. So if I look at something like this guy, again, I'm going to subtract the 75, so I'm creating space, moving this guy out of the way. I'm going to reorganize everything, so I've got the 9x squared minus the 90x with a little space minus 16y squared. The other thing that's nice, though, is it looks like it should be obvious which one of these I should write first and which one I should write second at this point. That could change in the end. Because the y squared has the negative, I decided to write that one second. And now from here, I can't complete the squared unless I have a 1 out front, so I have to factor out the 9. And the -16, respectively. And keep in mind that I factored out a -16 here, which means this leaves me with a positive 2y. And so that's the first place that this sign is going to mess us up, because that'll change our center when it's all said and done if we're not careful there. Then I do b divided by 2 and square it, that's a plus 25. Over here, b divided by 2 and square it, that's a plus 1. But now I didn't just add a 25 to that side, I added a 25 times 9, which is actually a 225. And then here the 1 is actually a 1 times a -16, which is a -16. And now I can simplify all this stuff. That's a 9, that's an x minus 5 squared. Minus 16 times y plus 1 squared equals 144 when I add it all up. And now I have to divide by the constant term just like I did with my ellipse. And again, the only difference here is that I have to deal with a little bit of those negative signs that can throw me off a little bit. So then I get x minus 5 squared, looks like over a 16, minus y plus 1 squared over 9 equals 1. And that's it. Now I can see the center, I can see A, I can see B, I'd be able to graph this whole thing. If I look at this one, same kind of thing, I'm going to move the constant term. So I add the 9 to each side. Right away, since I see the x squared is negative, I'm going to do the y squared and the plus 16y first. Just because it looks like it's going to stay that way, that's not necessarily true. I could end up with a negative on the other side, and then when I divide, it's going to change this whole thing, but that's alright. I'm always just going to put the negative listed as the second term. And now I have to factor out the 4 and the -25 respectively. And just be aware you're factoring out a -25 this time. So that gives me a plus 6x. And now from here I do the b divided by 2 and square it. That gives me a 4. Here that gives me a 9. But that's not just a 4, it's a 4 times 4, which is a 16. That's not just a 9, it's a 9 times a -25, so that's a -225. And now from here, I simplify this thing a little bit. Now the last thing I have to do is divide by that 100. So here I get y plus 2 squared over 25 minus x plus 3 squared over 4 equals 1. Now I can see the center, I can see A, I can see B, and I'd be able to graph this thing. Okay?